In this chapter, we will talk about the Dante Domain Manager server discovery methods, IP addressing, and network considerations for the different types of Dante deployments. In our Level 2 Dante certification course, we talked about the different ways Dante devices can be addressed. One of them was the DHCP. And if there was no DHCP server on the network, they would use link local. DHCP addressing is where the devices reach out to the DHCP server to get an IP address and other information required to communicate on a network. So, in this example, this device wants to join the network. So it asks the DHCP server if it can have an address. The DHCP server responds, "Yes, of course, here you are." Maybe that's not the exact response by the DHCP server, but you get the point. The other way devices can be addressed, which we also saw in Level 2, was via link local. The devices pick an address in the 169.254.0.0 to 169.254.255.255 range. This is done through a process called APIPA, or Automatic Private IP Addressing. The device then sends an ARP request on the network to make sure it's not already being used. And the last addressing method is static IP addressing. Here you assign IP addresses inside Dante controller that are allocated for each device. This way, they can be in the specific range you would like in order to fit in the same subnet. There are certain network installations where we may have to define static or fixed IP addresses for some devices. In those instances, and especially when there are many devices, we highly recommend using DHCP reservation to ensure that a device with a given MAC address will always get the same IP. One of the factors that can help you decide the type of network addressing is the size of your network. Imagine having to individually address 100 or 200 devices in Dante controller. Well, that can indeed become quite cumbersome and time-consuming, right? In those implementations, a DHCP server can be extremely helpful. On the other hand, 10, 20 devices may not be that hard to input static IP addresses on, right? If you remember in the Dante certification level 3, we talked about the different types of network traffic that help with varying functions like discovery. Let's recap some of that. In a single subnet environment, Dante uses a protocol called MDNS. The M stands for multicast. This is a fairly simple concept. Every device that is looking to be discovered like any of your Dante devices advertise themselves on the network using an MDNS responder message. Devices that are doing the discovery like your computer running Dante controller send MDNS query messages. Simple as that. For your understanding, Dante devices when first connected to a network will automatically start sending unsolicited response messages. This allows for a rapid discovery, rather than waiting for a query interval to pass at a Dante controller node. More information about the devices, which includes channel count, sample rates, latency, and so on, are then gathered using Dante API. This discovery method works great in a single subnet environment where there are potentially fewer restrictions on multicast traffic. As networks grow and begin traversing segments, this may prove too impractical. Let's talk about device discovery options in a DDM environment. At a high level, there are basically two options. You can do it with or without automatic discovery. Without automatic discovery, we can use manual enrollment, where devices are enrolled into domains using their IP address. Obviously, we would need to know the IP address and also ensure that the process is functional from a network setup perspective. Just note that if you change the IP of a device, it would no longer be visible to the Dante Domain Manager because we have enrolled it using a specified IP. The other option in manual discovery is to use Dante Controller. There is an option that says connect devices to DDM/Dante Cloud. With this option, Dante Controller tells the device where the Dante Domain Manager server is. Once this is done, the device will populate in the unmanaged devices list within DDM. A quick note, is that right now with these two options, the devices will report to the DDM IP. But we are soon implementing support for an FQDN or a fully qualified domain name. These options function even if you are implementing automatic discovery, which we will talk about next. In automatic discovery, the first method is using MDNS discovery, like we previously talked about. This would only function in a single subnet architecture. The process can be compared to how we can discover Wi-Fi devices on the same network as we are. Like, for example, a phone running your favorite music app, connecting to a Wi-Fi speaker or a printer. One of the drawbacks of this method is that we will not be able to use the high availability option that DDM offers you. The HA mode requires DNS for discovery, and MDNS cannot provide this. The second option with automatic discovery is what we usually recommend. In this fully automated process, we use DNS service discovery or DNS SD. DNS SD is a way of using standard DNS, programming interfaces, servers, and packet formats to browse the network for specific services. This can be used in both single and multi-subnet environments. DNS service discovery is compatible with, but not dependent on MDNS. This option will also require using a DHCP server to assign addresses and DNS server information to devices, along with DNS SRV records in the DNS server for DDM discovery. Let's review this in detail. We'll also do some live demos to reinforce these concepts. So, in manual enrollment, the first method of discovery is using static IP addresses. This method works in Dante networks on a single or on those that span multiple subnets. The networks will need to be configured to enable the routes, along with ports that will need to be opened to establish communication. Once this is done, the process is quite straightforward. Please note that this can become challenging in networks that have a large number of devices and lots of segments. When you manually enroll a device using DDM, the DDM server sends a message to the device using command or control messaging. It's like the servers telling the devices, hey, the server is at this IP address, enroll in a domain, to which the device obliges. It's like soldier receiving orders from the captain. Let me demonstrate this real quick. Our first example is using an IP address for manual enrollment. We are going to the first device that appears in the Dante controller to the hardware domain. The device name is Office DVS for reference. For that, we simply go to the DDM web interface, click on Devices, then Enroll Devices. After that, we select the domain where you want to put that device, which in this case is hardware, and type its IP address. And as you can see, it will automatically disappear from the unmanaged domain in Dante controller, and then enroll it into the DDM on the selected domain. If we navigate to the hardware domain in Dante controller, we will be able to see that the Office DBS device has been enrolled there. As a reminder, we could also upload a CSV file that contains multiple IP addresses to enroll several devices at once. Okay. The second way to manually enroll devices in DDM without this automatic discovery is a two-step approach where you can tell the devices to point to a DDM server through Dante controller. The devices will then appear under the unmanaged section of the DDM server, and you will be able to move it to the domain you want. Now, because there's no automatic discovery using DNS SD, and MDNS only works within the subnet, the DDM cannot see devices if it's in a different subnet. Once the Dante controller is logged into the DDM, it knows DDM's location and can share it with the device. It's like when you want to navigate to an address and ask your GPS app. It shows you precisely how to get there. Easy, right? The first thing to note is that Dante controller needs to be in the same subnet as the Dante devices that we want to push towards that DDM server. Once I do that, I log into the DDM with my Dante controller, then I go to the device menu, click on Connect Devices to DDM, and highlight the devices that I want to push to the DDM server. Click OK, and that's it. Dante controller is going to push the configuration of the DDM server to the Dante devices. And as we can see here on the DDM web interface, my two devices have appeared automatically in the unmanaged section. I do still need to move them to the domain I want them to be enrolled in. Drag and drop them to the hardware domain, and you can see they disappear from the unmanaged domain. If we go to the hardware domain in Dante controller, you will be able to see those devices. This option can also be used in a single subnet Dante network. We have just looked at the process for manual enrollment. Now, let's move on to the automatic discovery options. In single subnet systems, where both the DDM server and the devices reside in the same subnet, we can use link local or a DHCP server for addressing the devices along with MDNS for discovery. We've already talked about manually enrolling devices when they have static IP addresses. MDNS is always on by default. You could, however, turn it off if the network required you to. Once devices get enrolled into the DDM, they don't send out the MDNS queries or responded messages that they send out when they first come online. In a DDM environment, Dante controller is not really involved in the discovery of devices. Dante controller actually looks to the DDM to see what devices are available as opposed to having any part in the discovery process. In a multi-subnet system, where we hope to establish automatic discovery, we need to rely on DHCP along with DNS service discovery. The way it works is that the devices once enrolled in a domain remember where the DDM server is. For devices with 4.0 firmware version and higher, you don't have to worry if their IP address changes. You will, however, run into issues if the DDM's IP changes. When you set up your DHCP server for DNS-SD, there are two pieces of information that are critical. One, you need to make sure that the devices get specified the IP address of the DNS server. Secondly, we need to give out the domain name. For example, audinate.com, or like in this example, bestav.com. Please note that DNS domain and Dante domain are different and not related, so please don't get confused. The domains in DDM refer to cloaking domains, which we'll go into some detail on, and certainly don't need to be added to the DNS server. Also remember that the devices that have a static IP addressing via Dante controller cannot be discovered with DNS-SD, because it doesn't include any search path or domain field. The next step is to set up records for the DDM in the DNS server. With this, we can go to the DDM server using its fully qualified domain name or FQDN instead of its IP address. So for example, if someone installed a DDM and they set its IP address to 10.100.10.10, they could log in from the web browser by typing the IP address. If we did have an FQDN, which let's say is ddm.local, we could log in using that as well. This concept is similar to when we talked about that DNS works like a phone book for your network. We can also use the FQDN in Dante controller when trying to connect to the DDM. The server's FQDN will be referenced in the SRV record. Something important here is that if you change the host name from the default DDM, for example, my DDM, you'll also need to update the host name in the Dante Domain Manager administration menu. As we talked about before, the Dante devices and controllers can use DNS-SD when MDNS is not a viable option for discovery, such as in a multi-subnet Dante systems or in an HA cluster. DNS service discovery basically consists of two types of records: service or SRV records and text or TXT records. A service record is a specification of data in the DNS defining the location, for example, the host name and port number, of servers for specified services, for example, Dante. And a text record always has additional information, which in this case is empty. Since the domain was set up in the DHCP server with a path to the DNS server, when the devices come online, they query the DNS server for the location of the DDM. In our previous step, we described how the FQDN for the DDM is set up in the DNS server. The DNS server responds with the location of the DDM server, and the devices are discovered by the DDM. It may sound complicated, I know, but setting up a DNS server with records to services is something that IT departments do all the time, trust me. If you are not setting this up yourself, make sure you coordinate with the team handling this and, as always, start the coordination process early on in the project. This is an example of SRV records for a DDM system. Note that this is not the A record or address record that is used to map host names to an IP address of the host. When setting up FQDNs for services like the DDM server A records, will also need to be created as a standard practice. Here, what you need to know is that there's one SRV record for controllers on the network and another one for the devices. To the left, you can see an example of the format used for the Dante controller's entries in a Windows DNS server. Here, you will just need to adjust the domain as well as the host, which is the name of your DDM server with the domain. To the right, you can see an example of the format used for Dante devices in a Windows DNS server. Again, you will need to adjust the domain and the host like we did previously. Let's get into a demo to see some of these things. The first step in implementing automatic discovery is to configure the DHCP server. It needs to have a configuration with the domain name of your DNS domain. With this, when Dante devices are issued IP addresses, it also gets information about the domain and the location of the DNS server. Concurrently, we also need to configure the DNS server. When the Dante device contacts the DNS server, it's looking for information about the DDM. This is where we have specific SRV records under the TCP default Dante DDMC for controllers and UDP default Dante DDMD for Dante devices. Once this is done, both Dante devices and Dante controllers will be able to locate the DDM. Let's go a little deeper into the demo. If the configurations have been done correctly, the next time you run Dante controller and try to connect to the DDM, check the auto-detect server box and the FQDN of the DDM server should auto-populate. Behind the scenes, what Dante controller has done is it reaches out to the DNS server and asks for the Dante domain manager to which the DNS server uses the SRV record to point it to the DDM. If you are feeling overwhelmed with all the information, feel free to play it back again. DNS configuration is a routine task for a lot of IT departments. The very same process happens when Dante devices are connected to the network. The DNS server gives out the information about DDM using the SRV records on their UDP for the Dante devices. Irrespective of the subnet, the devices will populate in the unmanaged section of the DDM device list. From that point on, it's just about enrolling the devices into the intended domains in whatever way you want. We have previously discussed the enrollment process in detail. If you go back to Dante controller and navigate to the domain, you can see the devices have been enrolled and are displayed with variant subnets to which they belong. The routing process, however, is just like you would have in a traditional unmanaged Dante network. DDM gives you a balance between higher-level network facilitation while maintaining the simplicity of use we've become accustomed with Dante. Some of the most common questions that people ask us are about documentation. But don't worry, we've got you covered. We have a great information and guides targeting network administrators and on adding Dante to an existing network. Want to know what ports you will need to use for Dante? There's a document for that as well. These documents can be found on our website. Or as always, feel free to reach out to our solution sales team at sales@audinate.com. Audinate understands the importance of documentation, and we are constantly creating and updating this based on the ever-changing technology landscape. These documents are easily accessible on our website, where you can download them directly from the support portal or using the links you can find on the resources. This section talks about some important design considerations that are at times overlooked. When designing Dante networks that span multiple subnets, it's important to consider the flow count. Flow counts, if you recall from our Dante Level 2 certification, are a finite resource. Unicast is great when we want to send unique information to one destination. Sending the same information to multiple destinations requires it being duplicated, which puts a strain on bandwidth requirements, which, if you have multiple switches, adds overhead. This is why we leverage multicast within a subnet. Unicast will allow us to cross the router, so it's great for some applications, which DDM obviously can facilitate. But we need to be mindful that smaller devices, for example, those with a Dante Ultimo chipset, only have 2 flows. If one unicast flow is being used and there is still a requirement to send this to multiple devices, then we may have to use multicast within the subnet. Always remember that flow count doesn't always correlate to the channel count, and we need to plan for this during the design phase. Finally, let's talk about redundant networks in the Dante Domain Manager system. If you remember in the Level 2 certification, we talked about how redundant networks are useful when you want to have a secondary network as a backup for the first. If any cable or switch in the primary network were to disconnect or turn off during any transmission, the secondary or backup network would take over without any interruptions. Dante Domain Manager doesn't involve itself in the Dante redundant network path. In case a link was to go down, it supports redundancy, but only within a subnet. That means devices in different subnets won't be able to share audio if you set them up as redundant. The following are explicitly not supported for correct redundant operation in DDM. Devices in different primary subnets sharing a secondary subnet. Devices in the same primary subnet being in different secondary subnets. Secondary subnets using DHCP for address allocation. Only link locally supported on secondary. All devices disable DHCP on the secondary interface. In the example of a supported configuration illustrated below, there are 2 primary subnets, 10.10.60 and 10.10.70 are used as example address ranges, which are served addresses by DHCP. DDM enables audio routing between these subnets. The secondary interfaces for the devices in each primary subnet are connected to isolated subnets, using link local for address allocation. And just to say it again, audio routing is not supported between these subnets.